Hey there, someone had asked for some help with factoring, so thought we'd take a look at specifically two-term factoring. You should always look for a GCF anytime you're factoring, and you should ask after that, how many terms have I got? If you have two terms, you're typically going to be doing difference of squares, a difference of cubics, or a sum of cubics. So we're going to look at those three types of two-term factoring. So here, if I have x squared minus 25, or if I have x squared plus 100, x cubed minus 125, or x cubed plus 27. Only three of these four problems can actually be factored. We can work with a difference of squares, a difference of cubes, or a sum of cubes. So technically this is not something we can work with. Here I've got a sum, see the connector there was plus? Sum of squares, and so that's not factorable. But a difference of squares is. Here's what I want you to notice. Difference means subtraction, so we've got minus here, and we've got a square in the front and a square in the back. Remember that this could be rewritten as x squared minus 5 squared. So with a difference of squares, we can always break this into what we call a conjugate pair. You leave each parenthesis with just an x, and then you finish with the roots of your square. So here I've got 25, which leaves me with 5 and 5, but you've got to use opposing signs there. Once I do that, I can check this. This is the factored form, but I can check this by saying, okay, let's do basically the distributive property, but most of the time we refer to it as FOIL. So first times first, outside times outside, inside times inside, last times last. You'll notice that you get additive inverses here at the middle, and that's appropriate. That's supposed to happen. So these cancel, and I check to make sure what I did is equal to where I started, and in fact it is. Let's go ahead and take a look real quick at one more of those. If I had 4x squared minus 36y squared. Notice again, perfect square in the front, even the 4 is a perfect square, it's 2 squared. Perfect square in the back, even the back is a perfect square with 6 squared and y squared. So again, set up your double binomials. I'm going to load in the front with a 2x and a 2x. You can double check that by just multiplying them. 2x times 2x gets you 4x squared. In the backs, I'm going to take 6 and y, 6 and y. And the thing you've got to watch for is that you don't want to do this. You see what happened there? I put the same sign or the same connective there, and it needs to be one of each. This is the actual factorization of that. To check it, you're going to say 2x minus 6y, 2x plus 6y. And if I distribute, or FOIL, which is what most of us call it, I get 4x squared plus 12xy minus 12xy minus 36y squared. Do you see the additive inverses that showed up here again? Once again, as they ought to, and they sort of predictably do, they cancel each other out, and we get 4x squared minus 36y squared. Okay. When we take a look at the other two types of factoring, it's not going to be a difference or sum of squares. It's going to be dealing with cubics. Remember, with squares, we can only do differences, not sums. When we take a look at this, I want you to start with x squared, and let's go x squared plus 64. Oh, not squared, cubed. All right, so here we've got a cubic and another cubic, and it really helps to write these in cubic form to begin with. So I'll say x cubed plus, let's see, 4 times 4 is 16, 16 times 4 is 64. So you need to start beginning to remember 1 and 8 and 27 and 64. Those are numbers we get when we go 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. Those are cubics. So 64 is 4 times 4 times 4. And what we do when we factor this is we think about the formatting. This becomes my A and my B. And the way that the factoring will work is that I'll have A plus B, a squared minus the product of a and b plus b squared. This you have to memorize. This only works for when it's plus. So I'm going to get x plus 4. That's my a and my b. I'm going to square a, so that's x squared. I'm going to square b, and that's always the caboose. Both of these together multiply and produce the middle term. So I tell students, touch these two and multiply them. So a 4 times an x is a 4x. Now bring down the proper sign. Always, always a minus here. Always, always a plus at the back. I want you to notice that where it started plus, the front end stayed plus, the middle became the opposite, and this stays plus always at the end. Another professor says you should use SOAP, which is totally up to you. If this helps you, then good. This will be the same sign as it started. Same sign. This is opposite sign. And this is always positive. That will work every single time. Next one. If I have x cubed minus 8. I want to write this as x cubed minus 2 cubed. Now in this case, my a is x and my b is 2. And the setup here is similar, but not exactly the same. I want to say a minus b, a squared, plus the product of a and b, plus b squared. Now for this problem then, that means we're going to have, x minus 2, square this, load in the front, square the back, and load it in the back. Touch these two because when you multiply them, they become the middle term. Let's talk about signs. It started off as a minus, so I keep the minus. This will be the same sign as before, this will be the opposite, and this is always positive. So you've got your factored form. I have to run to class, so I'm going to stop this video. If you have more questions, go ahead and email me.